So the formula to convert from degrees to radians is pi over 180 times the degree will give you the radian. And when you put negative 240 over 180 and gunka pi, you put that in your calculator and you reduce it, it's negative 4 pi over 3. Convert each radian to degrees. You would take the pi over 4 and multiply it by 180 over pi. The pi's bite the dust, and 180 divided by 4 is 45 degrees. For the next one, we're going to find the missing side. So here we have an adjacent. X is the adjacent, and 9 is the opposite. So when you write out SOHCAHTOA, the one that has an A and an O in it is tangent. So tangent of 60 equals opposite, which is 9 over x. So x tan of 60 equals 9. And when you divide by tan of 60, you get that x equals 5.2. They want it rounded to one place, to the nearest tenth. This is also a tangent, SOHCAHTOA. And this is the adjacent to that angle and the opposite. So the tangent of the angle, you put the 24 there, equals opposite over adjacent. It's going to look the same as the last one. X tangent of 24 equals 14. Divide both sides by tangent of 24. And you'll get that x equals 31.4. That's 14 divided by tan of 24. The computer generated these, and they're all tangent, but then they might not be on the test, so just pay attention to up here. This is the opposite, and this is the adjacent. So we have tangent of 36 equals x over 10. So when we do 10 tangent of 36, we should get 7.3. And that is your answer. That equals x. This is also tangent. So tangent of 53 equals opposite over adjacent. So 11 equals x tan of 53. And you divide by tan of 53 on both sides. And x is going to be equal to 8.3. Now we're looking for the angle. When we're looking for the angle, you know you're going to have to push the second button. And here we have adjacent and opposite. So it's still tangent of theta equals 13 over 13. So that's 1. So second tan of theta equals 1. So second tan of 1 equals theta, and that was going to be 45 degrees. The next one is opposite and adjacent also. So tangent of theta equals 13 over 14. So tan negative 1 of 13 over 14 equals 42.9. So theta equals 42.9. The opposite, wow, we've got a non-tangent one for a second. So this is opposite and hypotenuse. So sine of theta is 2/5. So second sine of 2/5 equals theta, and that is 23.6 degrees. Equals theta. Another tangent is opposite and adjacent. Tan of theta equals 9 over 12. So second tan of 9 over 12 equals theta. and that is 36.9. Theta equals 36.9 degrees. So for all of these, you're going to draw a triangle that looks pretty much the same, and that the right angle is always C, and then A on the floor, and B is the way I do it. It doesn't really matter as long as you make sure you put little a and little c and little b across from those angles. So we're given little c goes across from big C, so that's 15, and little b goes across from 9 here from the big B. And so they want us to find the cosine of A. And in this case, cosine of A is adjacent over hypotenuse. So that would be 9 over 15. We do not have to find the third side on that one. So it's 3/5 when you reduce that. Sometimes you have to find the third side and sometimes you don't. Here we're going to draw the same triangle. And we have big C is always the right angle. That is not negotiable. So we won't have little c is 13 and little a is over here is 5. And they want us to find the tangent. When you find the tangent, you're going to need the adjacent. So we are going to have to find that. And we have that 5 squared plus x squared equals 13 squared. So x squared equals 144, which is 169 minus 25. It's actually a famous triangle. And x equals 12. So this guy here is a 12. And they want the tangent. And the tangent is opposite of A, because they want the tangent of A over adjacent. So there we go. So here we draw the same triangle. C, A, B. Little c is 7√5. Little b is 7. And they want the cosecant of A. Well, cosecant of A is the reciprocal of sine, so it's hypotenuse over opposite. And we're going to need we have the hypotenuse, we're going to need the opposite. So we have, we'll put an x here, x squared plus 7 squared equals 7√5 squared. And that's x squared plus 49 equals 49 times 5, which is 245. And then we're going to subtract 49 from both sides. Which is 196. So x squared equals 196. So x is 14. So now we're going to look at the cosecant as the hypotenuse, which is 7√5. I'm going to put it over here. 7√5 over the opposite, which is 14. And then the 7 over 14 reduces to 1/2, so it's √5 over 2. Here's another one. They want the tangent. So we're going to draw the same tired little triangle. And little a is 24. This is B up here. Sorry about that. And little c is 25. And then they want us to find tangent, which is opposite over adjacent. So we are going to need that side right there. And we would have x squared plus 24 squared equals 25 squared. So x squared equals 49. When you square root that, you get a 7. So now the tangent of A is going to be opposite, which is 24 over 7. This one tells you the secant, and the secant is the reciprocal of cosine, so it's going to be hypotenuse over adjacent. So I'm just going to draw the same triangle and put theta here, A, B, C. And if the hypotenuse is 13.5, that goes here. And if the adjacent is 19, it goes here. And they want the sine, so we're going to have to find that angle, that side over there. And it's going to be x squared plus 19 squared equals 13√5 squared. Be careful when you square 13√5. It's 845. And 19 squared is 361. So 845 minus 361 gives you 484. So it's x squared equals 484. So x equals 22, the square root of 484. And now they want the sine of that, which would be 22 over the hypotenuse. Can't have a radical in the basement. So it's 22 root 5 over 65. And that is your final answer. It cannot be reduced. So if the cotangent is 4 over 1, that means that the tangent of theta is 1/4. And we draw the same triangle, put theta in the same place here. And if the tangent is 1 over 4, it's opposite over adjacent. And they want the secant. You're going to need the hypotenuse. So it's going to be 1 squared plus 4 squared equals c squared. That's 17 equals c squared. So this guy's going to be square root of 17. And when you find the secant, it's going to be hypotenuse over adjacent. So it's square root of 17 over 4, because it's the reciprocal of the cosine. If cosine of theta is 3 root 13 over 13, that means that cosine is adjacent 3 root 13 and over 13. And they want the tangent, so they're going to need this side right here. So we have x squared plus 3 root 13 squared equals 169, which is 13 squared. 3 root 13 squared is 117, and 169 minus that is 52. So x squared equals 52. So when you square root 52, you get 13 times 4, and the square root of 4 is 2. So it's 2 root 13. So they want the tangent, which is 2 root 13 over 3 root 13. Those should bite the dust, and it should be 2/3. And that is the answer. So if the secant is 5/3, this is a pretty easy one because it's a standard triangle, it's a perfect triple. Secant is reciprocal of cosine, so that's adjacent over hypotenuse. And we also know that the third side is going to be a 4 because it's a famous 3, 4, 5 triangle. So the sine is going to be opposite over hypotenuse, which is 4 over 5.